Welcome to this lecture of Digital Electronics EI-207. In this lecture, we will discuss about registers. So the contents of this lecture will be, first we will discuss what registers are, and then we will discuss various type of registers like buffer registers, controlled buffer registers, data transfer in shift registers, that is the shift registers and how the data transfer takes place in the shift registers. Then various type of shift registers like serial in, serial out registers, serial in, parallel out shift registers, parallel in, parallel out shift registers, and parallel in, serial out shift registers. We will also discuss bidirectional shift registers and universal shift registers, and at the last we will discuss application of the various shift registers. So what are registers? So if we just discuss, or if we just try to define the registers, then registers are the set of flip-flops which store some multiple bits of data. So a flip-flop is used to store a single bit, whereas a set of flip-flops can be used to store multiple number of bits. So this set of flip-flops which is used to store multiple number of bits, and along with that they can also be used for data transfer from one device to the another digital device. So such circuits which can be used for two purposes, storage of the data and transfer of the data, are called registers. So this data transfer can be in the serial form or in the parallel form. Okay, this digital data, whatever is transferred, can be either in the serial form or in the parallel form as well. The data, if written serially, that means the data is written one after the another. Okay, when it is written parallel, or when we say it is parallel, either in the output side or on the parallel side, we mean that it is simultaneously. The occurrence is simultaneous. Whereas these registers are used not only for the data storage and data transfer purpose, but they are also used to perform various mathematical operations and to realize different type of counters. So this we will discuss in the last slide. We will discuss the various type of applications of the registers. So let's first discuss, so after discussing the definition and the various usage of the registers, let us discuss the very first register, which is called a buffer register. So a buffer register is a type of register which is used to store a binary word. Okay, this binary word can be of multiple bits. So this can be constructed using a series of flip-flops. So a buffer register, as you can see in the diagram, we have used a certain flip-flops, and all these flip-flops are clocked simultaneously with the same clock. Okay, now these flip-flops have one input, so all these registers, we are assuming that we are making it with D flip-flop. So we have used some D flip-flops depending upon the digital word which you want to store. Okay, so what is the word length? Here we are assuming that the word length of the digital word is 4 bits. So that is why we have taken 4 flip-flops. So depending upon the how many number of bits we have to process or store, we select that many number of flip-flops. Okay, so this flip-flop, this dip flip-flop, when they are connected in such a fashion, and you can see that each of the input of this D flip-flop is connected to some bit. Okay, B1, B2, B3, B4 simultaneously. Now whenever there is a clock which this clock occurs, if there is no clock, then the output will not get the value of the input. Okay, so when your input is stored, when the input gets transferred on the output, then you call it the flip-flop is loaded. Okay, or the register is loaded with a certain bit, with a certain input bit. So when the clock is 0, the flip-flop will not be loaded. Okay, it will be inactive. So all the flip-flops will be inactive if the clock is 0. Whereas if the clock is 1, then what will happen? The B1 will be loaded on the Q1, will be loaded in the flip-flop 1, okay, via D1, and it will come to Q1. Similarly, at the same instant, because the clock is connected simultaneously to all the flip-flops, so the one at the clock will reach to all the flip-flops at the same instant. So at the same instant, flip-flop 1 will be loaded with bit word 1, this bit 1 of the digital word. Then flip-flop 2 will be loaded with bit 2, flip-flop 3 will be loaded with B3, and flip-flop 4 will be loaded with B4. So these are called the buffer registers. Okay. So now let us see the another type of register. But first, before moving to the another register, let us see its timing diagram. So what happens, as I have told you, so let's say this flip-flops are age triggered flip-flops. So whenever there is a age of the clock pulse, then at that time the bit word, whatever is the bit word on the input of the flip-flop, gets on the output if whenever there is a this clock pulse or the positive age of the clock occurs. So at the first age, okay, so the word is there, so this is the word B1, so this is the input word, and to get this on the output, okay, so this will take place only when, so the flip-flop will be loaded with the input word only when there is a clock pulse. So age triggering, so whenever there is a clock pulse, then only the output will get the value of the input. Okay, so you can see it, and at some instance, let's say at this instant, okay, so now at this instant in the bit B2, although it is changing in between at this instant, but it will not be reflected, this change in the B2 will not be reflected on the output until the clock pulse doesn't occur. So you see here you can see that although the input changes, but it is not seen on the output. The reason is because the clock pulse is not changing at this moment. So when after this Q2 or the B2 changes, then whenever the clock pulse changes, the output will get affected only when the clock pulse change. Okay, so this is how you can understand. Whereas at the other places for B1 and B3, as you can see, the clock age occurs at the very first instant, so the output also gets returned at this instant. So what we are assuming here is the ideal case when there is no delay in the output, okay, or you can say when there is no propagation delay of the circuit itself. If you consider the propagation delay, then obviously the output will transit or will change only after the propagation delay of that particular flip-flop. Okay, if you assume it to be 0 for ideal conditions, let's say for the initial discussion, if we assume the propagation delay of the flip-flop as 0, then the output will change at that instant itself. So now let us see, because you see this buffer register is easy to understand, that is why we have discussed it very fast, but it is difficult to construct, okay, because you are directly connecting the inputs to the flip-flops and directly connecting the clock, so the simultaneous occurrence is very difficult. So what we do is, rather than talking about the direct buffer registers, we talk about the controlled buffer registers. So what are these controlled buffer registers? So these controlled buffer registers are the circuits in which the output is like you have some control in writing this input, okay, because in the previous case we didn't have any control on the input word. So whenever the bit word appears and the clock appears, then the output gets returned. So to overcome that problem of buffer registers in which we don't have any control, so that we can like control the input word, so we want some control mechanism. So to include that, we use controlled buffer registers. So in controlled buffer registers, we use a circuit, or you can see this line, okay, which is used for writing, for loading the buffer registers, okay, or for loading or writing the buffer registers. So to do this, what we do is, the circuit is same as the earlier one, but the only difference is we are using a new device here, okay, which is called a tri-state buffer. So a tri-state buffer on the input side and the output side we are using. So we can use them here, or we can use some combination of digital gates as well, okay, to control this. So basic idea is, whenever this load input is 0, then what happens? In one condition you will not be able to write on the flip-flops, whereas in the other condition we will be able to write it on the flip-flops, okay. So this is what happens. So we use this tri-state buffer. So this tri-state buffer have 3 states. So this is this red dot which you can see is the control input of this tri-state buffer itself. So what happens when this control input is 0, then this tri-state buffer is inactive, whereas when this is 1, then only this becomes active. So when, let's say, when this input load, this LD stands for load or load bar, okay, so bar is there, or you can write it as write bar. So when this is 0, what will happen? This will be inactive. So this input buffers will be inactive, and therefore this input will not appear on the input of the flip-flop, okay. Whereas when this load input is equal to 1, then at that time each of this tri-state buffers will be active, and when they will be active, so then in that case B1 will appear on the, you can say that B1 is you apply B1 on D1, on the input of the D flip flop, okay. Similarly B2 is applied on the input of the D2 flip flop, and B3 to the D3 and B4 to the D4 flip flop. So the load operation, this load terminal, or this load particular line controls your flip flops, okay. So you can control the write operation by the use of this tri-state buffer and this load line, okay, or the write line, okay. So this is what we do, and by this we can control the flip flop, and that is why it is called controlled buffer register. So there is a improvement in this flip flop from the previous flip flop. Whereas on the output side we can see that the data from this flip flops or this registers, the combination of this flip flops, okay, this register, this 4-bit register can be read if this RD line, okay, this red line, you can see this RD line is 0. So whenever this line is active, so whenever this is 0, so this will be active. So whenever this is active, then only we can read the data from this flip flops, each of this flip flop. If this is inactive, then we cannot read this outputs. So this is what about the controlled buffer register, okay. Now let us see the shift registers. So shift registers are of various types, so we will see them. So what happens in this shift registers are that these shift registers are used for various purposes. In this case of shift registers, you can see that the data can be either inputted in the serial form or in the parallel form. So here in this case, in this diagram, you can see that the data input is serial from one flip flop to the another flip flop. And why I am saying serially? Because the output of the first flip flop is connected to the input of the second flip flop. If the inputs are like separately tied to the input bit word, then they are called parallelly fed, okay. So in the previous case it was parallel input, so all the flip flops were getting the input separately, so then it is called parallel input. When the output of the first flip flop becomes the input for the second flip flop, then it is called serial, okay. So the shift registers, in the shift registers, the data can be transferred serially or parallelly. The data can also be we can input the data also in either in the serial form or in the parallel form, okay. So both the cases are possible. So here we can see that the data is like parallel. So in every flip flop, whether it is a shift register flip flop or the previous flip flops which we have seen, we have not shown, although in those flip flops the clear input, but all the flip flops, all the registers we usually have that clear input as well. So when this clear input is high, so this flip flops gets reset, okay. So the output will be resetted and it will be the output of all the flip flops will be 0, okay, will be clear. clear means the output will be cleared, so it will be 0. Whereas here also you can see that the all the flip flops of the register are connected with the same clock. Okay, so simultaneously they will get triggered. So data in is connected to the first flip flop, whereas the output of the first flip flop becomes the input to the second flip flop, and simultaneously the similarly the output of the second flip flop becomes the input of the third flip flop, and we take the output of the third flip flop. If we do this, then we call it a serial data transfer. Okay, now let's say what happens. So when this in shift registers, basically whenever you discuss any shift register, so on the occurrence of the clock pulse, then only the data gets transferred. So when this first clock age occurs, so Q1 data will be transferred. You see this Q1 is loaded on the occurrence of the first clock pulse. Then when the second clock pulse occurs, this data is transferred on the second flip flop. Similarly, when the third clock appears, the age of the third clock appears, Q1 will get transferred to the Q3. So you can see that on the appearance of the clock pulse, on the appearance of each of the clock age, the data moves from Q1 to Q3. Okay, so this can be represented in this form, which is called the timing diagram of the register, or it can also be written in this table form. So the meaning is same. So whenever this clock cycle, first at the appearance of the first clock cycle, let's say the data input word is your 100 100. So this is 100 100. So you see, when the first clock pulse appears, then the data input, the whatever is the data input, it appears on the output of the first flip flop. So you can see this. Okay, whereas when the second flip flop, when the second clock pulse appears, the same one bit gets shifted to the output of the second flip flop, and similarly when the third clock pulse appears, it comes on the output of the third flip flop. Okay, so you can see this. So you can represent the data in the tabular form, okay, or in this timing diagram form. So this is how this is what the working principle of the shift registers is. Now let us discuss the various type of shift registers. So because you see, when we say that the data can be moved in the registers, okay, can be transferred, so the data can be transferred in like 4 forms. So when the data is like the input is in the serial form, and also the output is in the serial form. So that type of shift registers are called serial in, because the data is the input is in the serial form, the data is incoming in the serial form, whereas the data is also exiting from the register in the serial form. So that is what is called serial in, serial out. Okay, as you can see that there are 2 possibilities, serial and parallel. So the data can be either serial form or the parallel form. So overall, the shift registers are basically of 4 types. Okay, serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. So we'll discuss each of them separately. So first we are discussing the serial in, serial out shift register. So as I have told you that the serial in, serial out shift registers, okay, in the previous case which we have seen was also the case of serial in, serial out shift register. So the serial in the previous case, we saw a 3-bit serial in, serial out shift register, whereas here in this case you can see, if you have n bit, so you can use n number of flip flops. And in the earlier case also, in this case also, you can see that the data input is here or the extreme left hand, and the data output is coming from the extreme right hand. So the data, and with the appearance of the every clock pulse, the data is shifting from this left flip flop to the right flip flop. Okay, so that is why it is called n bit or the right shift serial in, serial out shift register. Okay, so the data is actually moving from left to right, so that is why it is called right shift or the serial in, serial out right shift registers. Okay, so you can understand the working of this also. So the working is same as what we have discussed in the last slide, but this is a right shift register, right shift serial in, serial out register. So the working, as I have told you, we can understand it with the help of table or the timing diagram. So you can like this same thing what we have discussed already. So you can consider this. Okay, so bit by bit I have explained in every sentence that how it works. So you can read it out, and if you have any difficulty, you can ask me that in your tutorial class. So the other form of serial in serial out register is your left shift. So either the data can be right shift or the left shift. So the second form, I mean in the serial in serial out shift register itself, we have two forms, right shift and the left shift. So right shift was the earlier which we have discussed already. In the left shift also the arrangement is same, but physically the flip-flops are arranged in such a manner that the data moves from right to left. Okay, so you see here we are inputting the data on the this leftmost in the rightmost flip-flop, and with the appearance of every clock pulse, okay, with the appearance of every clock pulse, the data moves to the right, sorry, to the left. Okay, so that is why it is called left shift serial in serial out register. Okay, or left serial in serial out shift register. Then we have serial in parallel out shift registers. So what is how it looks like? So let us first see. So serial in parallel out shift registers. In serial in parallel out shift registers, again there is a clear input. So whenever this clear input is high, so all the flip-flops, whenever we have to start, we have to first give this clear input. We should make this clear input 1. So once we make this clear input 1, we are sure that the output will be all the outputs, all the previous states of the flip-flops will be clear. Okay, so there will be nothing on the output then in that case. Then once we have cleared all the entries of the flip-flops or all the bits of the register, then we apply the clock pulse, and as the clock pulse is appearing simultaneously, so with appearance of the first clock pulse, what happens? This data moves to the first flip-flop. Whatever data you are applying, it moves to the output of the first flip-flop. Then whatever is stored here, it will move to the output of the second flip-flop on the appearance of the first clock pulse. Then you can see that if we have already cleared the flip-flops, then there is nothing on the flip-flops. So on the appearance of the first clock pulse, the data input will move to the it will come on the output of the first flip-flop. Then when the second edge of the clock appears, then at that time the second flip-flop will be loaded with the bit word. Okay, so this is how you can see that it is you are writing it serially. So the input is in the serial form, whereas in this case, rather than taking the output just from the Q4 or the Qn flip-flop, we can take the output from each of the flip-flop separately. Okay, so if you can take the output separately from each of the flip-flop, then you can say that the output is appearing from this flip-flops separately, not at the not from the extreme MSB flip-flop. So it can appear separately at any instant from each of the flip-flops. So that is why it is called parallel out. So the output, the parallel, you are taking the output parallelly from each of the flip-flop. So that is why this type of flip-flop, this type of arrangement is called serial in parallel out shift register. Okay, and again it can be in two forms, left shift or the parallel right shift. Okay, so that doesn't matter, but the output will always be in the parallel form. So this we can see. So again I have explained you everything with the help of timing diagrams. So in the timing diagrams you can see the same thing which we have discussed earlier, or otherwise you can understand. If you have difficulty in understanding the timing diagram, you can understand the same thing the similar way which we have discussed in the last slide with the table form as well. So with the appearance of the every clock pulse, the data is moving. Okay, the whatever data you have applied on the input moves to the output of the Q1 on the appearance of the first clock pulse, age of the first clock pulse. Then on the appearance of the second age of the clock pulse, the data moves, the B1 moves to the output of the Q2. Similarly, for the Qn flip-flop, it moves on the nth clock pulse. Okay, for the nth clock pulse, the same bit will come on the nth output. Okay, on the nth flip-flop. So if it is if you are using 4 flip-flops, then on the age of the then on the fourth positive age, the Q4 will get the value B1. Okay, so this is how you can understand it. Same thing is written here as well. Now, so here So here we have to discuss this parallel in serial out shift register. So parallel in serial out shift registers, for parallel in serial out shift register, I have not shown you the timing diagram in the next slide. I am going to discuss it here completely. So what happens in this parallel and serial out shift registers, you can see the circuit for it. So this particular terminal here helps us to control the circuit. So when this terminal is 0, so when this terminal is 0, so what will happen? There is an inverter. So to make this parallel in serial out shift registers, we have to use some combinational gates as well. So these are our AND gates and this is our OR gate. So what we are doing is we are connecting one of them through this OR gate, okay, to the input via with the help of this load terminal. So the basic idea is what? When this input terminal is 0, so there is an inverter here. So what will happen? Each of this will be, the output of this inverter will be 1. So you see what will happen? This particular line here will become 1, and when this will become 1, this particular AND gates will be on. Okay, will get the input. So B1 will be connected to the D1 via this AND gate and this OR gate. Okay, so when this input is 0, so the circuit will be loaded. Okay, so the circuit will get input values. So it will be loaded with whatever input you have. So B0. So here on the first flip flop, we don't have to connect it to this particular thing because we are directly feeding it. Whereas for the other flip flops, we have used this arrangement. Okay, so this gates. Why we are using it? Because we have to move it in the serial fashion. Okay, so the output should come in the serial form. So that is why we have connected this gate to the output of the first flip flop. Okay, so that is why. So you see, whereas when this input line is 1, then this is 0, so this AND gates will be off, so they will be disabled. Whereas when the input line is 1, at that time this AND gates will be connected through this OR gate via to this D1. Okay, via this D1 through to this D1. Why? How? Because you see, this output then in that case will be transferred to the D1 via this AND gate and this OR gate when this input is 1. So when this is 1, this will be 0, whereas all these inputs will be 1, and so as they are connected with this AND gates, okay, so this AND gates, so then this AND gates will become active, and so the Q0 will come to D1. Similarly, when this shift is 1, okay, when this input line is 1, when this control line is 1, you can say it anything, you can call it anything. So when this is 1, then it will shift, so the data will shift in this direction. Okay, whereas when this is 0, it will be loaded, so it will be returned. Okay, so the input will be available in that case. So this is how your serial in serial out shift register appears, and as you know, it will also have some clear input also, although I have not shown it here, but it will also have some clear input, and when this clear input is becomes 1, though in that case the output will be cleared. Okay, so it will be deleted, all the outputs will be cleared, and the circuit will get activated with the appearance of each clock edge. Okay, because they are edge triggered flip flops. Okay, on the positive edge, so they are positive edge because you cannot see any bubble here, so it is a positive edge triggered flip flop. So they will get activated with appearance of each clock pulse. So when each clock pulse appears, then the output of the first flip flop, when the first clock pulse gets 1, okay, when on the appearance of the first edge of the clock pulse, the output of the D0 flip flop will be 1. On the appearance of the second edge of the clock, this will become active, and so on and so forth. Okay, so this is how you understand the parallel in serial out shift register. Now let us move on to the another shift register, which is a very simple one, and it is called parallel in parallel out shift register. Okay, so in parallel out shift register, you can see that the inputs are directly connected to the D flip flop, D input of each of the D flip flop, and the output is also available from each of the flip flops separately. Okay, whereas the clock pulse of all the flip flops is connected to a single clock. Okay, so that is why it is called, because the input can be written parallelly to the all the flip-flops simultaneously. Okay? It can be written simultaneously to the all the flip-flops. So that is why it is called parallel in, and simultaneously at the same instant the output can also appear on the each of the flip-flops. So that is why it is called parallel out. So it is a parallel in, parallel out shift register. Okay. Now we also have some other arrangement which is mix of, like, which is a hybrid register shift register, which is nothing but the hybrid of the left shift and the right shift register. So here in this case what we do, what we call it a bidirectional shift register. So bidirectional shift register is a register which can move its data in either in the right direction, right side, or it can move it in the, it can shift it in the left side. So the data can either shift in the right side, or it can shift in the left side. Okay. So this is controlled with the help of again with the help of a control line. So what you do, you connect an inverter here, a NOT gate here. So if when this line is 1, so what will happen, this will be 0. So in this case all of this gates, you can see the second gates in each of the flip-flops will become deactivated. Okay, when this line is 1, whereas when this line is 0, then this particular flip-flops will be, sorry, when this line is 1, okay, when this line is 1, so this will be 0. So when this line is 1, so this flip-flops, this AND gates will be enabled. So if this this flip-flops, this AND gates are enabled, then in that case data will, because you see the data is the output of the first flip-flop is connected to this AND gate. So whenever this particular AND gates become active, okay, this particular AND gates becomes active and this AND gates become active when this line is 1. So in that case the data shifts in the right direction. Okay, whereas when this line is equal to 0, in that case the data shifts in the left side, because in that case what happens, this flip-flops gets activated. Okay, when the line is, this line is 1, then this AND gates, all these AND gates becomes activated. When this input line is 0, in that case this flip-flop, this AND gates becomes activated. Okay, this AND gates becomes activated, and so the data shifts in the left direction. So from the connection it will be very easy to understand. You can see that the data, how the data moves in, can move in both the direction. Okay, so obviously it also have the clear input and the clock. So we know how this clear and clock pulse control the circuit. So the same thing happens here in this case also, what we have understood in the previous cases. So the clock and the clear input works in the same way as it worked in the previous cases, whereas to control the data in the left direction or in the right direction, we have to use this control input. Okay, so when this is 1, it moves in one direction, when it is 0, it moves in the other direction. Okay, so this is how you can understand it. Now moving on to the another flip-flop, okay, you can understand its working. So whatever I have told you here is written, same is written here. You can read it out, and if you have any confusion you can clear it in the you can ask me in the doubt class, okay, on the tutorial class. The same you can understand with the help of the timing diagram also. So you try it by your own. In case of problem, the method is same, you can ask me in the tutorial class. Now we have